what can be done. So in essence, what is profilers? In software engineering, profiling or program filing, or even software filing, right? So we can call it software engineering profiling, program profiling, and software profiling is a form of dynamic program analysis that measures, for example, the space. When we talk about space, we talk about memory, right, guys? Or time complexity of a program, the usage of the particular instruction or frequency and duration of the function calls. The most common use of profiling information is to aid program optimization, right? So that's kind of when we talk about tools, we talk about profilers. And when we talk about profilers, we're talking about software profiling. When we talk about software profiling, we're talking about using a program to optimize the actual potential and the growth of a certain service or application or software, right? And then the last one is technologies, right? And I'm just going to hover over it so you can see. And technologies or technology, okay, when we talk about in the testing world, is performance testing technology employs one or more PC or Unix servers to act as injectors. Each emulation of the injection emulates the presence of numbers of users, each running on the automated sequence of interactions. Now, remember when I told you the previous time or in a previous video or so, I spoke about, we kind of do testing to avoid hacking for banks, for example. And this is like, when we talk about technology, we have PC and Unix servers that kind of mimics a injection to kind of measure where can we go with this. Like it emulates where we can go with this. Because at the end of the day, hacking, a form of hacking is SQL injection. And that's kind of one thing you definitely want to avoid, especially when you have any website that you've built from scratch and so forth. So to get back to our technology, when we're looking at the emulating of present number of users that gets injected into the actual testing environment, we can see that the automated sequence of interactors record as a script, right, or as a series of scripts to emulate different types of user interactions which the host whose performance is being tested. Okay, so I'm just going to back up and repeat that because it's important. If you don't catch this, you're not going to understand anything, right? So I'm going to go back and I'm going to repeat this. When we look at emulation, right? When we look at PC and Unix servers that emulate an injection into our service application, database, website, I can go on, mobile application, whatever you're testing. When we look at the technology behind the injection of what happens, and I'm going to repeat it again, is that the technology that we use to emulate, right, the number of users of each running an automated sequence of interactions, we record it as a script. So every time when we inject something, it gets recorded as a script, right? And that's kind of where when we get back to, what we're going to do here is we're going to work with scripts in essence, right? And if you use testing technology like HP's technology or JMeter, we definitely gonna have scripts that get recorded, right? And that is how in essence you can do that. So usually a separate PC acts as a testing conductor, coordinating and gathering metrics for each of the injectors and collaborates the performance data for reporting purposes. The usual sequence is to ramp up the load. Okay, that is important. We want to ramp up the load so that you want to put strain on it. You want to put some stress on it, right? And starting with a small number of virtual users and increasing the number over a period of some maximum time. Now, when we talk about that, we're going back to okay. Now we're starting to add virtual users. So we're looking at load testing. So if we go back, and I'm going to take back the slides. Now we're looking at load testing, the first one over there. And then we add some users, and then we're going to have a look at stress testing, right? And we add and we add and we add users, and then we look at soak testing because it's the duration of that adding and adding and adding. So getting back to what I've spoke about, the technology or the technologies that gets used acts as a virtual, okay, a virtual injection or injector, and that gets recorded as a script. The script we use in our testing software, right? So the test results show how the performance varies with the load. Given as a number of users versus response time, various tools are available to perform such tests. Tools in the category usually execute a suite of tests which will emulate real users against the system. Sometimes the result can reveal oddities, right? And that results that gets reviewed are scripts. That software we use to test are the ones that we're going to work with, right? The software that we're going to use is LoadRunner. We're going to use LoadRunner to emulate this, right? And while the average response time might be acceptable, there are outliers of few key transactions that take considerably longer to complete. Sometimes it might be caused by inefficient database queries, pictures, etc. So I'm just kind of saying, like, sometimes, you know, you get a form where the testing takes too long, and the reason for that is because of inefficient databases and or pictures or queries or whatever. You know, for every single project it's different, right? So performance testing can be combined with stress testing, okay? And I'm going to go back to put emphasis on it. So performance testing is kind of, one thing about performance testing is it is combined with stress testing. In order to see what happens when the acceptable load is exceeded, does the system crash? How long does it take to recover? How long does it crash? How long does it get back up on its feet, right? And does it fail? And how does it fail? Why does it fail? How quick can we fix it to, and avoid the failing in the future? So yeah, there's a lot of things when we get to testing, but it's quite an exciting subject, because it kind of goes like, you've created the software, you created this application, created this service, and now you got to put it through some testing to make sure that it actually works the way it should, right? The way it was supposed to. And when we look at the way of getting that to do, we need to test it. When we look at testing, we look at two different testings. We look at functionality testing and we look at performance testing. When we look at performance testing, we look at NFR, which is non-functionality requirements, or even NFT, which is the same thing, which stands for non-functionality testing phase. Okay, so analytical performance modeling is a method to model the behavior of system in the spreadsheet. So when I speak about APM, it stands for Analytical Performance Modeling. It's a method, okay, to model the behavior of a system in a spreadsheet. The model is fed with measurement of transactions, resources, and demand. Like, for instance, a good example is, for instance, your CPU, your hard drive, your LAN. If you open up your task manager, it kind of gives you a result of what your hard drive is doing, what your LAN is doing, network doing, what is your CPU doing. And that's kind of what APM, architectural performance modeling, does, right? It's a method that we follow to kind of get that algorithms and get that on a spreadsheet, right? So the model is fed with measurement and transaction resources demand weighed by the transaction mix business transaction per hour, okay? The weighted transaction resources demands are added up to obtain an hourly resource demand, and also divided in an hourly resource capacity to obtain resources loads. Using the responders formula, okay, which we'll have a look at later on. The formula is a bit, tricky, but it's very straightforward, but we'll look at it in the future, right? You'll use this formula to kind of, work out, okay, how does this application contain towards other applications? How does the testing, collaborate to, let's say we have another side which is very similar to this, right? So that is when we look at technology, and it's a big subject, and we will go through this as we go through this subject. We will understand more about it. So the next thing I want to talk about is tasks to undertake. Tasks to undertake is kind of another thing that you have to understand. And if you want to undertake testing, you got to undertake your tasks, right? Okay, so when we look at tasks to undertake in testing, and especially performance testing, it's the following. Okay, I wrote there internal, external resources. So when I talk about internal, external resources, I talk about deciding whether